All right, today's topic is 13-2, which is recursive definitions. Today's date is today, and our objective is to use sequences defined recursively to solve problems. In our last lesson, we did it with explicit, where we actually have a formula, and we just kind of do some plug and chug. Recursive is going to be a little bit different. So for recursive, you have to look at what your initial condition is. Where are you starting? Well, in this case, our first term is 3. And then a recursive equation or definition is asking, what are you doing each time to the previous, from the previous one? Well, I think this one's pretty obvious. You're adding 4. So you take 3, add 4 to get 7, so forth. So the equation on this would be, get t of n. You're taking your previous term, and that would be n minus 1. And n minus 1 just means the one before it, and adding 4. So if we wanted to get t sub 6, t sub 7, and t sub 8, all we're doing is we're adding 4. 19 plus 4 is 23, 27, 31. A recursive definition is going to always consist of two things. And you need to make sure that you understand a recursive has to have two different things. When you take your test and your quizzes, both things have to be on there to get it correct. An explicit, which is what we did in our last lesson, is just one equation. Recursive is telling where you start with an initial condition, and secondly, an equation that tells you how each term in the sequence is related to the preceding term. I would not be surprised if you see that question, what does a recursive definition consist of, on a lesson quiz. So, let's go ahead and look at this example again. We figured out the terms 6, 7, and 8 by just adding 4. But let's get a recursive definition of that. That would be t sub 1 is 3. And what you're doing is you're taking your previous, term and adding 4. So that would be your, that says reclusive. That should say recursive. That looks like that was a typo. And that would be the two things that you would need there. Your initial condition and what are you doing to the preceding. For the explicit, that's what we have been doing. That's where you want to write an equation. Well, this one's obviously arithmetic, and your difference each time is 4. So if I were going to write an equation there, it would be your starting point, t sub 1 plus n minus 1 times 4. Let's actually distribute this time. So t sub n would be negative 1 plus 4n. This is explicit. This is recursive. So let's go ahead and do a couple examples. We want to find the second, third, and fourth term of each sequence. Then we want to state whether it is arithmetic, geometric, or neither. Well, they tell us our first term is 2. That should be a subscript there. T sub n equals 3 times t to the n minus 1. So if I want to figure out what t sub 2 is, that would be 3 times t sub 1, because if I could always just look at that right there and do 2 minus 1, that's where that 1 comes from, and plus that would be the preceding for the previous term, which would be 3 times 2, or 6. T sub 3 is going to be 3 times t sub 2, which would be 3 times 6, or 18. T sub 4 would be 3 times t sub 3, which would be 3 times 18, or 54. So our sequence there is 2, 6, 18, 54. That one is obviously geometric because you're multiplying by 3. Well, and that makes sense because you're taking 3 times. Let's do another one. This one is a little bit different because they're actually giving us the first 2 terms. T sub 1 is 2, T sub 2 is 4, and then they're giving us t sub n equals t sub n minus 1 times t sub n minus 2. That n minus 2, t sub n minus 2, just means that it is the term 2 places before. So let's go ahead and figure out what t sub 3 would be. Well, that's going to be the preceding n minus 1, which would be t sub 2, times t sub 1, because that's 2 spaces in front. Well, they gave us both of these pieces of information. That would be 4 times 2, which is 8. T sub 4 is going to be t sub 3 times t sub 2, which would be 8, which we just figured out, times t sub 2, which is 4, which is 32. So our sequence there, it's 2, 4, 8, 32. Let's go ahead and figure out t sub 5 just for fun. That'd be t sub 4 times t sub 3, which would be 32 times 8, which would be 256. Well, this one is neither geometric nor arithmetic, so it's an neither. Let's go ahead and find a recursive definition for this one. Well, what it looks like is happening is you're multiplying by 1/3 each time. You're dividing by 3, which is the same thing as multiplying by 1/3. So we always start off with what our initial condition is. What is our first term? Our first term is 81. And then the second piece of information that we need is what are we doing to the previous one? Well, you're taking the previous one and you're multiplying it by 1/3. That's it. Hope you enjoyed.